Alright, ladies and gentlemen, so we're going to try something a little new in preparing for this upcoming quiz. I'm going to work through the problems on the review sheet that I gave you, and I'm going to start with the simplifying of radicals. All of the problems that I have here are all simplifying radicals with numbers only. It seems like while it's not the only method that can be used, your favorite method with problems like the square root of 72 was to use the prisoner method, in other words, to break 72 up into its factors. So we'll do 2 and 36. 36 is 6 and 6. 6 is 2 and 3. And 2 and 3. And as Mr. Bree has liked to do for you guys, he likes to bring all of those factors down on one horizontal line. We're going to look for any pairs. So I see 2 2s, and I see 2 3s, and then I have a 2 that is left all alone. Well, that 2 that's left all alone is inside my square root. And from the 2 3s and the 2 2s, I'm going to cross 1 out from each pair. So that leaves me with a 2 and a 3 that are out in front, which together make 6. So that's how I get the first problem. Below it, the square root of negative 5 squared. So we know that a square root and a squared cancel each other out. But we need to recall that because this is a positive radical, we're going to have a positive 5 as our answer. And it's okay that this negative is inside the radical because it is being squared. It is not just a negative inside the radical. Which is different from both of these problems, in which I also have a negative inside the radicals. In the fourth root of negative 16, I have a negative inside an even root. Anytime I have an even root and a negative value on the inside, that is not real. We're not going to deal with I this chapter. We're just going to say it's not real. Now, if I have a negative on the inside of an odd root, that just means that my answer is going to be negative. The cube root of 27, hopefully we recognize it as 3 right away. Okay. Otherwise, we might break it up into 9 and 3. 9 is 3 and 3. We have 3 3s, cross 2 3s out, and we're left with the 1 3, and that also is how I get my answer. With the square root of 0.49, I'm trying to trick you with the decimal point there. Ignore it. So the square root of 49 is 7. Now, realize that I have a value with 2 decimal places. So in order to have 2 decimal places in my product, the thing I'm squaring must have 1 decimal place. 0.7 times 0.7 equals 0.49. So the decimal point looks like it's tricky, but it's really not. And last but not least, the square root of 32, very similar to the original problem that we did. I'll break it up, 16 and 2, 4 and 4, 2 and 2, 2 and 2. So I have 5 2s. I'll circle my pairs, cross 1 out. So I have 4 on the outside, square root of 2. So that's how we would simplify all of the numbers beneath radicals.